Okay, whenever I was trying to decide what I was going to do for my capstone, I wanted to incorporate what I'm interested in, which is like nuclear power and engineering. And today in the current world, the biggest use for nuclear power is like in nuclear reactors for electricity and also in nuclear powered submarines. And so that really drive my interest. I also, when applying for college, I applied to the Naval Academy because they have a really good nuclear engineering program there. And so I kind of want to incorporate that into my capstone, but also gain knowledge about like if I would really like that after I graduate from high school and college. Just a brief history about Oak Ridge and ORNL. The Manhattan Project was started in the late 1930s, and it was where the nuclear program originally began. Most of the work was done by German scientists. Albert Einstein was really important. He notified the United States that Germany had started their own nuclear program and that the United States should begin one as well. While the nuclear bomb was designed here, it was tested in New Mexico. The company that I work-based learning with was UCOR. It's a Department of Energy contractor that handles over $2 billion in contracts over a 10-year period of performance. And the main goal of the company is ETT Site Cleanup, which is the East Tennessee Technology Park, which is not on ORNL's main area, but it's kind of in Harriman. And steps in that is, facility deactivation and demolition and site restoration. The process is to ensure like all radioactive material and all contaminants don't get into the ground and are disposed of properly. Two big buildings out there that have not been destroyed, but they are really prevalent in the Manhattan Project are the K-27 and K-25 buildings. They are both gas diffusion facilities, which are used for enriching uranium and designing the atomic bomb. For example, the K-27 building, which is this one right here, was 1,400 feet or 900 feet long, 425 feet wide, with 4 floors, including a basement and a 20-foot ceiling. It was built to be a functioning building in 18 months. Just imagine how long it would take to build a building today in the same size. So the project that was completed right before I started learning out there was the K-27 building. It has multiple steps for deactivation. Deactivation is just a general term for the complete removal of all the contaminants from inside. So the first phase is cold and dark, which is mechanical and electrical isolation from the building. So all wires and pipes and anything that's coming into the building is either shut off or taken out. Next is characterization. This is probably the most important part of the phase. It's where they go through the entire building and mark every little thing and determine where it should be disposed of. Deactivation, the subtitle for that would be hazard abatement, which is they go in and remove all the asbestos and lead and mercury. Mercury was really prevalent in the light bulbs. And universal waste is just a generic waste items that may not have radioactive material but still need to be removed before they can destroy the building. And equipment removal is all the heavy machinery and bigger equipment pieces are removed. And when they remove those, they can't just take them out and put them in a landfill. They have dump trucks that come and they put them in there, and before they leave the technology park, they're scanned and make sure that they do have radioactive material in them and also covered. But they also have a specific road route that they have to follow, because if one of the trucks was to leak, then they would have a nuclear fallout, but it could be minimized. The K-27 building, for its demolition, the main parts were size reduction and waste hauling. The size reduction is just what it sounds like. They would get an excavator and bulldozers, and they would just take the building down piece by piece, starting from the top to the bottom. And this was the shorter phase of the deactivation and demolition. And after that, there was the waste hauling. Like I said, it was really important that they secured all of the waste properly and disposed of it in the right area. Here's a K-27 building project schedule. This is just a layout of all the different steps for it. You can see here it's like K-27 deactivation, and it has like the time period. So this was about a 5-year project. The deactivation was 3.5 years and $118 million, while the demolition was half the time and only $50 million. The big problem with deactivation is just the safety risk. The people that go in to the building have double layer gloves, full like body suits on, and double layer foot and boots. The next step is site restoration. It's essential for restoring it to future industrial use. So once the building is destroyed, there is just a concrete slab that the foundation was on. And so they remove that, and after, the soil that's underneath it may or may not have contaminants in it. And so they have to test every part of the field. And if there is contaminated soil, then they have to remove it and put fresh fill dirt into it. That, after it's filled with fresh fill dirt, is considered a greenfield estate, which can be reused for industrial use. Also, the underground holes in basements are filled with concrete to make sure that while they're working, there's no other safety hazard. My mentor is Steve Torval. He's actually my uncle, but he's a project control manager for UCOR. He has an applied mathematics degree and 30 years in project management. He really helped me understand that if I just continue to strive towards my goals, then I can achieve whatever I put my mind to. What I did, like I said, I shadowed a project controls manager. I learned about what his daily role is in his job. Also, I experimented with P6 software, which is Primavera, and developed this schedule for building a house. It really helped me see that whenever you're constructing a schedule, it's really important to make sure you have every detail in it. So whenever I was doing this, I had obtained land, but then I went to frame foundation, but I forgot about, clear it and grade it and make sure it's certified to build on. So it really helped me just think of a bigger picture and better planning. Also, I prepared a time phase cost profile and critical path. So this is the critical path. It's just the longest string of continuous activities. And the ones down here have to be done before or after the ones above it are finished. So that really just helped me plan better. What I learned is that workers out there range from union workers to PhD level engineering. And so I could use my analytical skills and logical conclusions to determine a schedule, but also I would have to interact with different types of workers. One of the downfalls I saw out there was that the union workers, since the project would be over, if they finished their job quickly, then their job would be out basically. So they could kind of take as long as they could just to keep their pay coming in. And also with that, there's nuclear safety engineering that determines the risk of a nuclear fallout if the building was not contained properly. And so I think that was really important and really insightful into my own understanding. And here's a video to further explain the East Tennessee Technology Park. It loads, yeah.
At sites across the nation,
It's not working.
Department of Energy is focused on environmental cleanup of legacy waste generated from decades of weapons production. In Tennessee, that focus is currently on the former K-25 gaseous diffusion site that enriched uranium for defense and energy missions for more than 40 years. Industrial processes left behind radiological and chemical contaminants in buildings, equipment, and soils. To complete cleanup of the East Tennessee Technology Park, workers will demolish 6.5 million square feet of facilities and structures. That's the size of 113 football fields. That's what the Department of Energy and its cleanup contractor, UCOR, face as they clean up the World War II era site. Major activities to achieve site cleanup include deactivation, demolition, soil and groundwater remediation, and waste disposition. Deactivation crews, predecessors to the demolition team, remove contaminated equipment and piping, and other hazards that cannot be disposed of with building debris or pose unacceptable risk during demolition. It takes about 3 times longer to deactivate a building as it does to demolish it. A A building can't come down until contaminants have been identified and characterized, with those exceeding regulatory limits stabilized and removed.
We need to make the building ready to do an open air demolition so that if you do by chance have some dust come out of the building, it's not going to be a hazardous material that will affect the environment or the public.
In the demolition phase, crews are pulling down the structure, disposing of debris, and stabilizing the site to meet final regulatory requirements for closure.
Supporting the demolition here on our side of the house, excluding the disposal cell, we will have somewhere around 125 people that is supporting this operation.
More than 90% of ETTP cleanup waste will be disposed of on-site at the Oak Ridge Reservation's Environmental Management Waste Management Facility. Waste destined for on-site disposal at EMWMF adheres to rigorous standards to keep communities and the environment safe.
We're taking a hazard and containerizing it, we're disposing of it, we're treating it in the way that it needs to be treated.
Cleanup at ETTP will continue through 2020 as the remainder of site structures are demolished, soils remediated, and waste disposition in support of the site's transformation into a private sector industrial site, historic landmark, and conservation area.
And so, like you saw, the misters that were shooting like mist up on the building when they were destroying it was to ensure that no airborne particles got away from the building if they were radioactive. And also, this really helped me understand like what I want to do. I thought it was really interesting about how the whole process worked. And if I end up going to UT, then I will major in nuclear engineering. But also helped me not see that nuclear engineering is sitting in like a TVA reactor, but also I could be like a safety engineer and be out in not really like on a project, but just out in the general area and just interact with other people. And that's it.
Very nice.